All right, friends. This is an added lesson this year, not added work. In previous years, we assumed incorrectly that we taught enough at that point for you to be able to handle multiple triangles. Maybe you just need a little bit of guidance on this. It's not bad. I'm probably not going to teach anything new today that you don't already have. But there's just going to be some overlapping triangles, that's all. Some good tips on dealing with problems involving more than one right angle triangle. Locate and label all triangles. Identify shared sides and angles. I'm going to talk about that a lot in this lesson. Identify the shared sides and angles. Ones that are in both, those are key ones. Highlight what you need to find. Decide if you want trig ratios or Pythagorean theorem, but work systematically. Solve for one unknown before moving on to the next. You may need the results from one triangle to get answers in the other triangles. Well, some of those tips will be better to look at when you're doing homework, not while I'm teaching. While I'm teaching, I'm going to talk about all these things, so hopefully we'll handle all of that in stride. Switch to my smaller pen. Here we go. Solve for the length of CD. Lots going on here, and that's the main challenge, is to go, what am I after? What can I do? So I'm going to teach two methods at once. The first method is make a great plan. Make a great plan. Sometimes this works in geometry and trigonometry. Sometimes it works to be able to plan the whole thing out. Let's try and plan this together. If they want the distance CD, if I just cover my hand up and only look at that side of the picture, in fact, I'll get our revealer out here for the sake of the video. If I just look at that side of the triangle, do I have enough information in that triangle to find CD? No. Well, let me tell you a secret about about triangles. It's actually true for all triangles. If you don't have 3 pieces of information, you're toast. You need 3 pieces of information. I argue I only have 2. I've got this angle, and I got the 90. There's only 2 things I know the answer to. 2's not enough. Can't be done with 2. So I argue at this moment I can't do anything to get CD. If that was the problem. If I gave you that problem in the test, you'd be like, can't be done. And I don't mean can't be done by you. I mean can't be done by anyone. No one from just one angle and a 90 can figure out a triangle. It needs more. Okay? I'll turn off the revealer. Will I? I'll turn off the revealer. Okay, so here's us making a great plan. A great plan would involve, well, that means I need something in this triangle. Can you use the right-hand triangle to find something in the left-hand triangle? Yeah, because they got a shared side. That's what that opening note said, shared sides. In fact, for some of you, let me get out a highlighter, and I'm just going to highlight in pink, very carefully highlight in pink, that shared side. That might be the whole planning process here. Shared side is key. If I can find that side in the right triangle, I'll have it in the left-hand triangle. Ooh, let me say that again. That's good sentence stuff. That might be good enough that you might be like, you know what? I'm going to go to sleep now. Because I got it. I got the plan now. The shared side, if I can find it in one triangle, I'll have it in the other triangle. That's good stuff. Okay? Well, that's me making a good plan. And sometimes I've done things like this when teaching this. I go, oh, okay, well, that means if I look at this and go, oh, I could get this if I wanted. I'll put a little smiley face on it. I could get this if I wanted to in the right-hand triangle, because in the right-hand triangle, I've got 3 pieces of information, angle, angle, and side. And then I look at the left-hand triangle, oh, well, if I have that side and I have that angle, then I can solve for CD. Well, you don't have to put smiley faces on yours. Ooh, that was not too smiley. Now he looks like he's got a mustache. That's good planning. It goes, I know exactly everything I'm going to do. I'm going to find AC, and I'm going to use that to find CD. And sometimes in geometry, we can make a full plan like that. But sometimes we can't. So now I'm going to teach another way, which will end up with the same steps, but I'm going to teach another way to do this problem, which is to go, I don't know what to do. I don't know how this thing's going to play out at all. So I'm going to look at the picture and find anything I can. See? Completely different plan. It takes less thinking. It's a little scary because you're like, I don't know if this is going to work, but I'll find something. But it's good for part marks. Let's say you can't finish a question. You at least get part marks. Looking at the right-hand triangle, I'm covering up the left-hand triangle in my brain. What sides can you find? The middle line, that AC, I can definitely find the AC. I could also find the BC. I could find this angle up here. Because there's 3 pieces of information, with the weapons we've given you for SOHCAHTOA and Pythagorean theorem and angles, as soon as you got 3 pieces of information, you're rolling. Remember, by 3, I also count the right angle. That's going to matter when we switch over tomorrow to things that don't have a right angle. Still going to be 3. 3 is going to be the magic number. 3 pieces of info, we can do everything. Yeah, that'll be enough for us to do everything. So, in the middle of all that, you go, okay, well, I don't know exactly how this question is going to play out, but I certainly could find this, and I'll label it H, because H is a really good label, I think, in this particular case for height, but can mess you up with hypotenuse a little bit maybe, but okay, you'll get good at managing the letters. Now I'll just do my steps. I'm going to use this angle, and if I'm going to use this angle, what side is this called? The 8. Hypotenuse. Do you see why I said don't just write H? Write hype for hypotenuse, because H came up in this question and you don't want to get confused. What's the H in the question? Opposite. So then I go, okay, opposite hypotenuse. So sine of 35 equals opposite over hypotenuse. Listen, friends, do I need that line anymore? That's up to you. That depends on how much practice you've done. Some people already were finding shortcuts and going, sine 35 equals h over 8. They were jumping right to that without writing that first line. The first line is almost like the trig training wheels. Remind yourselves, opposite over hypotenuse. You practice it enough, though, you'll be much faster. Okay, continuing to teach the way I've taught these lessons. Can you type sine 35 in your calculator? Yes. Yeah, that's a big hint that I won't need sine inverse. I have the angle. I can just go ahead and type sine 35. And if you have even more shortcuts than what I'm showing, that's all fine. 0.5736. And I want to talk about this 4 decimal place thing a little bit and put it in perspective. I'm about to take this 4 decimal place situation and I'm going to multiply it by 8. Do you see what's going to happen when I multiply by 8? All the decimal places are going to move. And so then it might only be accurate to 3 decimal places. Maybe in another question I'm going to multiply by 25. Now it's only accurate to 2 decimal places. So if I want my final answer to be accurate to 4, to 1, I keep 4 along the way in the hopes that my answer is going to stay accurate no matter what happens next. Okay? Is it a perfect guideline? No, no, no. There's better guidelines coming on these things. But in grade 10, in the hopes to avoid confusing the whole issue, we say use 4 decimal places, and then that's a great chance at things staying as accurate as possible. Okay? All right. Who's got this last step? What do I do now? Times it by 8. Yeah, okay. So all that work we've done in algebra all semester comes in to kick in here so that this step hopefully is easy. From a calculator standpoint, though, if you're getting experience with your calculator, I don't have to retype that all in. I can just hit the multiply button, and it says, oh, take the answer that you had from the previous one and multiply by 8. And actually, that keeps all the decimal places, so I know this is actually very accurate because it kept all the decimal places. So I get 4.6 as the height. And maybe you see a hole in my procedure. If I round this now to 1 decimal place, is it going to be accurate in the next part? And the answer is no. I shouldn't round to 4.6 here. I should give us more here to give myself the best possible chance. So 4.5886. And do you have to do that? No, no, I'll probably accept it in grade 10. if you get off by 1 decimal place. But be aware in your homework, if you don't keep a bunch of decimal places as you go, your final answer might get thrown off by a decimal place. You know, you look in the back of the book, you get, say a final answer, you get 12.7, and it says 12.6. You probably didn't keep enough as you went along. And that's going to become an issue as we move along. And if, in the future, if you want to be a scientist or an engineer, you have to be very cognizant of how many decimal places to keep to make sure my answer stays accurate enough. Because once you start multiplying and dividing by stuff, it can get thrown off. Anyways, I encourage you to label your diagram when stuff like this happens. That's why I was on about that on a previous lesson. I said, label the diagram, because it really helps to help you decide. And if you had a great plan, you know what has to happen next. If you didn't have a great plan and you're just like, well, I can get this side, well, I can get that side. Now we look and after everything you find, you look and go, well, can I find what they want now? Can I find CD? Do I have 3 pieces of information in the new triangle? The answer is yes. And now I can find CD, which I'm going to call this X instead of CD. Me personally, I don't love carrying around CD as a label, but if you like it, you can do it. So in this triangle now, is 4.5886 still called opposite in this triangle? Yeah, it still is. That doesn't have to happen when you switch triangles. Sometimes the names will change. Yeah? And what's the X in this triangle? Adjacent. So now I'm doing cosine in this triangle. Cos 25 equals X over 4.5886. And back to teaching. Oh, it's TOA. Thank you. I was so on about my rounding that I chose incorrectly. I didn't have to erase all that, did I? No, it's tan. 25. Thank you for catching that. I would have been so sad if my video, had had a mistake in it. It's happened before. Yeah. It was horrifying. Hopefully you're not. Wouldn't that be funny if you were watching this video in a future class because you had to remind yourself, well, I'll go back and watch Mr. Todd's video. And then you heard your own voice.
Wait,
Wouldn't
you
you
have a
be?
YouTube channel?
Yes.
You post it on there?
Yes.
Mr. Todd's teaching.
It's all right. I don't mind a few interruptions. It just got a little away on us a couple of days there, didn't it? Uh-oh, SpaghettiOs. This is a problem. Oh, I'll get to the problem. You think about what the problem is. Can I type tan 25 into my calculator? Yeah, okay. So then I don't need tan inverse because I can do tan 25. 0.4663. And I'll try and do some great teaching here and write this in such a way that hopefully many of you go, oh, I know what to do.
All you do is take 4.586 and divide it by 0.46.
Well, that's true, but I'm not sure everybody's going to want to make that leap. I want you to cross multiply, yeah. I want you to put that over 1 and cross multiply because this is not the same situation. The unknown's in the bottom. And there's other ways to handle this, by the way, friends, including flipping both sides. You know, there are other ways to handle this, but cross multiply is the most reliable. Yes?
Is it not just the same as moving the X over?
He says, I don't need cross multiply. Can't you just bring X over and multiply by X? Yes. That's what I said. There are other ways to think this through, but I'll teach cross multiply every time because it's the most reliable in most situations, okay? And we'll definitely need it tomorrow, yeah? Now, so it ends up being divide, which Olivia claims she saw coming, which I believe her. I'm just trying to say, yeah, you can see it coming, can't you? Sometimes. This is where the practice comes in, right? Some of you are really starting to engage with the idea that, oh, practicing isn't about whether I understand it or not. Practice is about, can I do it? 4.5886. Can I do it quickly and easily and make sure I get and have time to check if I got right answers? So there's more to practice, right? It's easy to say, Oh, I get it. Why do I have to do the homework? So you get it and can do the question quickly. Did you get 9.8 while I was talking about all that? Did you type it in? Did you get 9.8? Or are you just messing?
I did get 9.8.
Oh, yeah, I did get it. Okay. Meters. Me personally, not every teacher's like this. Me personally, if the question's algebraic, I'm happy with an algebraic type answer. If the question's in words, it better be a word answer. That's where I draw the line. But be aware, as you go into other teachers' classes, maybe they want a better therefore statement in these situations as well. Okay? Do you have any questions about that one? Was there anything new in that example, really? Was there no real math that was new, but a new approach, maybe? Question? Sometimes. I'm going to teach sine law and cosine law in the next couple of days. And because this wasn't, you could think of this as not a right angle triangles, sometimes we'll be able to, yeah, there's more to the story. Yeah, we could think of this in a bigger picture here. But it actually, the sine law comes from doing two right angle triangles and going, oh, there's a pattern to this. So it's not really escaping right angle triangles. It's just shortcutting it. A lot like the quadratic formula did. Quadratic formula was just completing the square. But it just shortcutted it for us and said, okay, here's where you're going to end up. So it gave us the final answer. Tristan.
Would I still get 9.8 if I then like changed tan 25 into like a number? Like I just kept it as tan 25 and then like cross multiplied?
Yeah, in fact, if you kept it as tan 25, chances are you'd actually be more accurate. So when it happens in your homework that you get an answer, final answer in one of these like 9.7 and it says 9.8, I think you should live with it. Because that's not a problem with the process. What we should do in every step is keep as many decimal places as we can, and that's how we'd stay accurate if we were an engineer or a physicist or a chemist and we needed more accuracy. For our purposes, we're working on the technique, and we will talk about those decimal place things as we go through the grades and get closer to actual applications. Okay? Solve for the side length AB. Well, let's switch over to good planning. Yes? If you get into a question on a test, on a quiz, in the homework where you're like, I don't have a good plan, just start finding what you can. Yes? But let's make a good plan here. My good plan looks like this. If they want AB, I'm going to label AB with a little X there, going, that's what I want to find. That helps frame what I'm doing. Then I look at the triangle that X is in, over here, and I check out what I have in there. Do I have enough information? It's even worse. That's not even a right angle triangle. This other one's a right angle triangle. So I'm going to just highlight that one and say, well, that's a right angle triangle. And here's my $1 million question. Can you find some information in that right angle triangle that is related to AB? What do you want to find? The hypotenuse will be in the other triangle. That is true. That could be helpful and will be helpful tomorrow, actually, when we don't care about right angle triangles anymore. But here today we're sort of stuck with right angle triangles. He says I can find this angle over here. It's a great idea. You know, it's really too bad. Because in tomorrow and the next day's lesson, we'll do stuff like that. We'll just go, let's just get over to this triangle. Because I'll hand you a new skill. I'll hand you the ability to handle triangles that aren't right angled. Unfortunately, in today's lesson, because we can't handle non-right angled triangles, going over to that second triangle is not going to help us all that much. So let me rephrase my question again. Can you find some information in this right side green triangle that doesn't give me X, but is related to X? Yeah, this BC side I think is going to be helpful. Okay? I'm going to label it that way this time. I'm going to call this BC. I'm going to go, okay, in this triangle, if I'm going to use the 40, what's 400 called? Opposite. And what's BC called? Adjacent. Don't mess this up this time, Mr. Todd. OA. Tan. So tan of 40 is 400 over BC. This time I'm going to use the label BC. I'm not going to let my own approaches affect what I'm showing you in class. So I'm going to solve for BC here. I don't know. Let me show you something fun, shall I? A shortcut in all this that I think a lot of upper year students use, and maybe as an AP class you'll enjoy this. Watch this. I'm going to do what I said, put tan 40 over 1, but I'm not going to punch it into my decimal, or into my calculator and get the decimal. I could, but I'm not going to. Instead I'm going to do this. I'm going to cross multiply and go BC times tan of 40 is equal to 400. I'm not going to type it in my calculator yet. This is how older grades avoid this whole decimal problem. They go, hey, I'm not going to type it in until I absolutely have to. I don't want to have to write down 0.4638 or whatever it is. Then I'm going to isolate. I'm going to go, okay, that means BC, oops, is equal to 400 over tan 40. No decimals, no questions about rounding, nothing. I'm all in there without doing as a decimal. If you do as a decimal, wherever you see tan 40, you'll write your crazy decimal, and then I can go right to my calculator and do the rest. 400 over tan 40. Do you get 476.7? Nice, right? Nice. That's a nice way of doing it. If you did it with the decimal, and you did tan 40, you would have got 0.8390, and then you would have taken 400 and you would have divided by 0.8390, and you would have got 476.75, and you would have gone, oh, it's actually 0.8. That's what I'm talking about. In your homework, if it's off by 1 decimal place, it might just be when you rounded that affected your answer. Okay, that is important. I'm going to write that in my diagram. In here, this AC is 476.7, there to there. Oh, this is hard. This is difficult. We're going to need somebody who's fully awake to help us with this one. What's we don't have right angle triangles today. What's the other right angle triangle? Bronick. He says there's another right angle triangle. And let me phrase this carefully. In DAC, can I find a side that's related to the answer I want to get? Yes. AC would be good to have, wouldn't it? If we could get AC, we're pretty much home. So over here in pink on purpose, 10 of 25 this time is opposite over adjacent, but don't let me away with it, friends. Get to the point where you either look at that and you're like, I have no idea what you did there. Or you're like, oh, I get that. One of those two. And then we'll argue about it. Tell me now if it's not okay. I'll be glad to explain what's happened.
I don't understand.
You don't understand?
No, because why'd you do AC? Because you don't have that.
I went in the pink triangle, and I'm going to go after AC now. Once I have AC, I already have BC. I can finally get what I want. I'm going to subtract in the end. Yeah? Is it good? But, because I want to do great teaching today, this time I won't do my fancy way. I'll just get the decimals. Can you put tan 25 in your calculator? Do it the other way. I love the other way.
What other way?
0.4663, where you don't get a decimal to the end. But I am going to steal Liam's way. I'm going to say, hey, to bring the ACO, I don't need to cross multiply. I'm bringing AC over here, so it becomes 0.4663 times AC. And so then AC is 400 over 0.4663. And either way you do it, you should get 400 divided by answer equals 857.8. If you're off by 1 decimal place, no big deal. I'll accept it. It just changes. It just changed by when you rounded things. Might have got you off by 1 decimal place. We'll get better. By the time you become an engineer, we'll do better about rounding, and we'll know when to round and how much to round. Whew!
Did you go to engineering?
I did not go to engineering school. I went to Waterloo for math. I took many of the courses the engineers took, though. Because I took applied math, many of the courses I took were taken by mathematicians, computer science people, and engineers. I was sort of in the middle of all that.
Did you graduate with a bachelor's in mathematics?
A bachelor's of mathematics, that's what it was called, yeah. Okay, so now who's going to tell me how to get AB after all that? Tristan. AC minus BC. That would have taken longer with my no plan of attack. By no plan of attack, I mean I'll just find the things I can find and hope that I eventually get what I want. The planning's better. So what was it?
381.7.
What'd you get? Meters. And again, me personally, it's sort of an algebraic question. It's not a word problem. I'm okay with an algebraic answer. But other teachers and profs might not be. So maybe then you need a nice therefore statement in the whole thing. But that's personal preference, I think. Okay? Do you have any questions about that one? These take practice, friends. The good news is you get to practice all your SOHCAHTOA within them. Like if you did no homework this chapter at all, but you did tonight's homework, might work out. I'm not saying you shouldn't have done another homework. I'm just saying this homework is way more important than the previous ones.
Mr. Todd, I have a question.
Yes, ma'am.
Okay, so basically, if I had if I had B to D, and then if I had that number, and that is 62.37, then couldn't I do tan?
No, because it's not a right angle triangle. But I don't want to say too much about it because tomorrow and the next day, I'm going to give you the weapons you need to do non-right angle triangles, and you could do this exact question in a different way tomorrow.
That's what
Hey, I
I
can
did,
solve that
because
Rubik's
I
Cube.
did it in a different way, because I did
Can
it
you solve
before
Rubik's
she
Cube?
did it.
I can too. Can I try?
You won't get the right answer.
I didn't.
Yeah, you won't. You won't. If you use SOHCAHTOA, and hey, I'm going to get a lesson ahead of you. Let me get a lesson ahead of you here. If the triangle's not right angled, you cannot use Pythagorean theorem, and you cannot use SOHCAHTOA. So apparently I'm going to show you something else. Yeah, okay, and we will get there to that. Okay. Example 3, solve for angle theta.
Theta. We haven't used theta in a bit.
Mr. Todd, don't need to.
I just want to talk about one thing, and then we'll see if somebody's got a plan, okay?
I'll lock in for this, Mr. Todd.
Yeah, good. Let's just look at that right-hand triangle. Are you given 3 pieces of information in that right-hand triangle?
No.
What are they?
Actually, yes.
Yeah, but you're not given theta. Right? You don't have that amount. If you had that amount, you're right. We'd be off to the races. We have 32, and we've got 90, but we're not going to be able to make it just on that. And if someone's got a plan for us by staring at the whole situation, I'd love to hear the plan, but also some words to help people. Can you see the plan of attack?
Yes.
What would you go after? You're all saying the right things. He's saying the middle one, you're saying RQ. This one here. And I'm going to label it H. You could call it RQ, and if you like calling things RQ and solving for them, me too. I generally give them a single letter. H. Why is H so important? Why does that fix the problem? What is it about H?
Because then you get the adjacent of theta.
Yes, yes, then you have the adjacent of theta and you're off to the races. Because this side is common to both. You want to make good plans, look for things that are common or related to what you're after, okay? So we're off to the races here, I think. In the right-hand triangle, let's see. What side is H? And what do we have? Hypotenuse, so we're talking about sine. I don't know why I put 340 there. That's equals opposite over hypotenuse. Trying to switch back and forth for people who like the decimals versus don't like the decimals. I don't have to punch sine 34 in just now. What's the opposite of dividing by 15? So I get 15 sine 34. Punch that right in my calculator. Eight. Okay, so let's do a little more on these decimals here, because hopefully the trig is starting to come for you. How many decimal places would you keep here? Yeah, keep 4, because we want to stay accurate until we get to the final answer. We don't know what's going to happen in the right-hand triangle, so if we want to stay accurate, we keep a lot here. 8, 3, 8, 7, 9. Did I copy that down right? And if you keep only one decimal place, and then you bring it over to the other triangle, and you do the answer, and your final answer is off a little bit, I'm going to take it. That's not my point there. My point is why we keep 4 decimal places is so that our final answer will still stay within 1 decimal place. I'll give you an example to understand what I mean. Let's say together as a class we're manufacturing something, and I tell everyone in the class to make sure your answers are within a millimeter. Every cut you do on, let's say we're woodworking, and every cut you do has to be within a millimeter. As a class, how much could we be off when it was all over? 3, 4, 7, 9, 10, 13, 16, 18, 21. We could be off 21 millimeters by the time it's done. So if I got to be within a millimeter, I got to make sure all of you are within a hundredth of a millimeter. So we got to be more accurate early on so we don't get thrown off in the total of things. Yeah? All right. Speech over. What's the rest of the plan now?
Cos theta.
He says cos. Cosine. That's okay. I don't care about that. But I'm just telling you. It's cosine. He says it's cosine. How did he do that so fast?
Because I saw adjacent.
He saw adjacent hypotenuse. Do you really need to label the sides? I don't know. If you've done a lot of practice, you might be at the point where it's like, I don't even need to label the sides. I can just look at them and I know which ones they are. That's fine. I like it. But maybe you're still labeling, and that's good. I've got grade 12s who still label the sides. So I get cos theta. This is real. No, I'm saying it. Cosine theta, 8.3879 over 32. Can I type cos theta in my calculator? No. So I want to move cosine over to the other side. Now, when you move things over in equations, add becomes subtract. Subtract becomes add, multiply becomes divide, divide becomes multiply, squared becomes square root. What does cos become? Cos negative 1, which again is called cos inverse, but most people call it cos negative 1 for a long time. And then you just type that in. I don't know what's happening. (75 degrees). Generally, we go to the nearest degree, because degrees are already small. If you go to extra decimal places, that's fine, but degrees are pretty tiny to begin with. So to round to the nearest degree is usually lots. Yeah, tell me.
Yeah, what if PQ
If we knew they were parallel, we could have jumped right to this angle. And that would be 34. Yes? And then we could jump right to there. But clearly, that didn't happen. And so, watch out. Diagrams aren't meant to be to scale. So even though you go, well, it looks like it's the same. No. When we draw these diagrams, we're not drawing them perfectly. We're just saying, it looks something like this. Our job now to figure it out without using sort of visualization to get the answers, yeah? Does that help? All right. How are we doing? 2 more examples? No, 1 big example. 1 big example left to go, right?
It's on D2L. It's on D2L.
What is? It's on D2L, yes. The PDF is, yeah.
No, like,
The completed is not.
I wrote it, it's not?
The completed version is not on D2L yet, because I'm making it right now. Yeah? Eventually, these completed notes have to come from somewhere. I'll put this up here as soon as I finish.
Okay.
And the video.
I accidentally just canceled it when I tried to redo something.
Oh, okay. Sorry. This will be up there. This is exactly what you're seeing here. Like, exactly.
Okay.
This is the one that's becoming the completed one.
Okay.
Yeah.
I got it.
Stop has 1 syllable. We've been over this. All right, listen to this one. This is a showstopper. This is the crazy one from the chapter. Even the stuff I'm going to teach the next 2 days isn't as bad as trying to decipher what the heck is going on here. It is now. Roxy, whose eyes are 1.6 meters off the ground, is standing on a cliff 130 meters above the water. Roxy looks down at an angle of 57 degrees from the horizontal to see Logan about to be eaten by sharks. Roxy then looks up at an angle of 46 degrees from the horizontal to see Nyla flying a rescue helicopter. Nyla is directly above Logan, and due to weather conditions, he cannot lower the helicopter any further. Nyla wants to help Logan by sending down a 220-meter long rescue ladder he has on the board. Will the ladder be long enough to save Logan? Dun, dun, dun. He thinks so. Well, let's draw a few things on here to try and visualize what the heck's going on here. First, a cliff. Cliff. Yeah? Good so far? And then Roxy is on the top of the cliff. And I'm going to label her R eventually. That's Roxy up there. I'm already unhappy with my diagram. I know why, too. Let me just make myself some space. Oh, that's going to be a problem, isn't it? Oh, that's not going to size well. You don't have to change anything, but I do, okay? Because I made the diagram too big. You'll see why in just a second.
Oh, okay.
Yeah, if you made it just as big as me, it's going to be a problem. And maybe you'll see in just a minute what I'm talking about.
Oh,
Cliff. Roxy. There we go. That's better. And water. Do you see why I had to go lower? Can you already see what's going to happen?
I see.
Yeah. He's looking up. Roxy, I think, is the girl's name, but that's okay. So there's Roxy, and then in the water.
No, it's okay.
Allow it. Allow it.
Who's in the water? Logan? Logan. Got it? Roxy looks down at an angle of 57. That's the angle of depression. I'll do that in green.
When they say from the horizontal, you mean from the eye level?
Yes. Then she looks up and sees a helicopter. Can I draw a helicopter? How's my helicopter looking?
Actually, it's not.
Not that bad. For me, that's pretty good. And here comes my first really good teaching of the example. It could be that all of that you might have gotten and then been at a standstill to know what to do next. I'm going to do two really important things. The helicopter is directly above Logan. That's straight down. But here's the most important line I'm going to draw. And we talk about it in physics and calculus all the time. Draw on the horizontal. For Roxy, the horizontal to her eyes is right there. And as soon as you draw that line, happiness returns to the kingdom. Because you're like, two right angle triangles. Everything's going to be all right.
How are they two right angles? No, they're not.
Vertical,
Got it.
horizontal. Yeah? Good. Now, what's the angle down to Logan? 57. What's the angle up to the helicopter? 46. Sometimes we put little arcs on there to make sure people know which angle we're talking about, so you can see.
How is the cliff under the water, my boy? It has to start from the water.
Well, cliffs go underneath the water.
I mean, that's what I'm saying.
That's what I'm saying. How far? I actually know one of the sides here. I know something. Tell me what's something that's in my diagram that I know? It's not the 220. The 220 I'm going to have to use at the end.
Oh,
Is it going to be 220? What do you know?
no, you remember
I mean, you know it's 130, also she's like 1.65 off the ground.
Yeah, we know this one here. Here comes my fancy.
Oh my gosh. You know I did it yesterday and actually did well. Can I do it on the board?
Maybe. How far is that? How far is the water up to Roxy's eyes?
131.6.
I don't see 131.65 anywhere. Where are you getting that from?
You take them and add them
Oh, the cliff's 130.
together.
And her eyes are another 1.65. So anytime they mention the eyes, it's just something you got to add in at some point. It's not really a big problem. This is 131.65. I already know part of the answer. Is it going to be 220? Well, it's at least 131.65. The rescue ladder's got to be at least that long. So now the big question. What am I really after here? What spot do I really trying to solve for?
This straight eye level line.
What do you mean?
No, for the freaking the helicopter to the right angle.
The helicopter to the right angle. This is what I really want here. I got to do something with it, and we'll get to that at the end. But that's the piece of information I really need. Does that upper triangle, do I have 3 pieces of information in the upper triangle? No. So what side am I really going to have to go after?
The eye level.
The eye level, the common side. That common side is key, which is what you said, right? Get the common side. And again, that's been woven through the lesson a whole bunch of times. Get the common side, or get the common angle, and then you'll be off to the races. I'm going to do that work here, and then I'll do the other work on my next page. Okay? So in that triangle, I'm using 57. What two sides are involved?
Adjacent and opposite.
So we're doing tan. Tan 57 equals 131.65 over D. How many people would switch this to decimal right now? Would you go to decimal right now? Yeah, some of it would. How many people would be like, no, I don't want to write the decimals? The vote, 21 people, and the vote was tied 1-1. Reminds you of all the Canadian elections, doesn't it? Yeah? Nobody voted. Oh, okay, whatever. Okay, I'll do it without the decimal then. D tan 57 equals 131.65. If you do it with a decimal, you're going to get D times 0.86, whatever it is. Then you'll do D equals 131.65 over tan 57, which if you're doing decimals, it'll be equal to
85.49456.
I'm going to type it in for the sake of the video. Divided by tan 57. And what do we agree? 85.4945? Why am I taking all the decimal places here? I'm going to use it again, so I better stay accurate here because we're going again. And I'm going to write that on my diagram. Okay. Are you happy? No, not happy? What does it all mean? Yeah, I don't know. I don't know. I don't know what it all means.
Hey, Mr. Todd.
I know I'm supposed to know.
Yes, you did.
I know you're hoping I know. But nobody knows.
I know.
You know what it all means?
I know what everything means.
Now what? I need that X.
So what you're going to do is you're going to go up to the top one because now you have 3 pieces of information. You're going to use tan 46.
She likes tan 46 equals opposite, which was the X, over adjacent, which was my 85.4945. Just to go AP a little bit, we didn't even have to type this in. We could have taken this and made it the D. 131.65 over 1057, then taken it along and divided it by or multiplied that. So you can keep perfectly accurate if you want to. Yes? But we don't have to do that here, okay? I'm just dipping my toe in that going, we can, there's ways to make this all stay perfectly accurate, by the way. Where's your iPad?
I left my iPad at home. Math booklet, not here. I'm struggling.
Just having a day, yeah.
I know.
Me too. I've had a horrible day. Brutal. Brutal, brutal, brutal. Something about December, eh?
Mr. Todd, when is summer school days?
Why? Because next month we're done being in class together? Is that what you mean?
Are you going to miss Mr. Todd, me and Olivia? Please say yes.
Well, it depends whether I'm addicted to quiet or not, I guess, doesn't it?
No, Mr. Todd, you're
Hey,
going to miss
Mr.
us.
Todd.
I'll visit you. Don't worry.
Do you need more time here?
Oh, yeah.
Last night I saw your child's spareware, and I'm gonna go in
No,
the
go up, go
system
up.
and find your.
You're going to what?
I
This
saw
is sounding creepy all of a sudden.
sweater.
Can you get this girl
It said Chloe Todd. I said I was gonna go in the system.
Oh, a dance.
Yep.
Yeah, we were
I'm
very
gonna go in
excited.
the system and find your address, but I already know it.
Yeah, we got about 5 emails yesterday. This came in, this shipped in, like it's all falling into place.
How'd you guys get packages?
What do you mean? How do we get there? You just get to package to us.
But there's a strike.
They shipped it some other way.
There's no way Canada Post has like the only shipping company.
Yeah.
Well, for a lot of, it's kind of frustrating.
They're just the least they're just the least expensive one, that's all. And they can get everywhere. That's the other thing we're finding out.
What?
Canada Post gets to everybody. Where sometimes Peer Later goes, oh, we don't go down that road. You know what I mean? Like, so that's where Canada Post is an advantage. For those of you who live in cities and stuff like that, you're like, well, what do we care? Who needs Canada Post? Well,
You do, Mr. Todd. You don't live in a city. You live in.
you're right. Peer Later went to drop something off the other day and left me a note because they wouldn't leave it at my house. Yeah? Did you get 88.5? Okay, bonus question coming up. Bonus question coming up. What is it about the angle that made it so that 85 was so close to 88?
Oh, Mr. Todd, I got that answer.
What angle is this? 46 is really close to 45, really close to an isosceles, so the sides are really close together. Oh, we don't need that here, but anyways. Am I done? No. And I don't mean a final statement. We're not done calculating. Yes. Helicopter to, who's the swimmer? What was the swimmer's name? To Logan. Distance. Now we find out. Is he going to get eaten by sharks? Is he? I don't know. What was it? What 131.65? Plus 88.5.
I got 220.182.
Was it?
I like added more.
No, it looks like, oh, is it 220?
Yes, it was 220.1.
Oh, I don't think it is in mine. I don't want to write a different number. Yours might be more accurate than mine. You might have kept more decimal places.
More decimals and like the X.
Yeah, I think mine's 220.15. Yeah? I forget. How long is the,
It's 217.
wait, do we agree?
Typed it wrong.
Meanwhile, Logan's down there going, just drop the ladder, stop calculating. 220.15. Are we good?
Yeah, I got
What's the word? Logan?
he's dead.
220. Oh. It just reaches. Okay, it's going to be okay. It will be okay. If Logan can reach 0.15 meters up. Yeah. Yeah. If he's already underneath the water, it's over. Yeah? But if he can just reach up 15 centimeters, it's going to be okay. Have you ever seen the movie The Martian? In The Martian, they do an on-the-fly similar calculation of this, where they're trying to figure out, based on the velocity of the guy they're rescuing and the amount of cord they got, and they're like madly going, is it going to be enough? And they go, it's not enough. And then they had to come up with a new plan because it wasn't going to be enough. Yeah? Have you seen the movie? Best movie ever. The Martian. Yeah? Do you have any questions?
What's like the eye length?
It came up only once. Instead of writing 130 here, we wrote 130 plus another 1.65 to get that distance up to her horizontal. Yeah? It only came up one little moment. If you forgot about it, we would have ended up calculating that we were fine. The ladder was going to make it no problem, and it wouldn't make it. So that's interesting that we cut it that close.